Now in section 4.3, we're actually going to expand on the idea of stoichiometry to look at even more complex situations where we have multiple ingredients where some of them might run out before the others do. Let's go back to our example again of this crust and pizza making formula and use that at first to develop the ideas behind this limiting reactant type concept, and then from there we'll again move to chemicals. So let me ask this. If I have this set of ingredients together, 4 cups or 4 crusts, 10 cups of cheese, and 15 ounces of sauce, how many pizzas can I make with that? So our plan here basically is just to figure out how many pizzas I could make with each of them individually, and then go from there to figure out and compare and see what number of pizzas I think I'll actually be able to make overall. So let's try that. For crusts, that's a 1-to-1 ratio. So I should be able to get 4 pizzas if that's the only thing holding me back, is the crusts. I have 5 ounces of sauce, and 5 ounces of sauce. I'm sorry, I don't have 5 ounces of sauce. I have 15 ounces of sauce right there. So I have 1 pizza every 3, no, getting out of myself, 5 ounces of sauce. There we go. So again, I'm just looking up here in 1 pizza for every 5 ounces of sauce. That's my conversion. That makes 3 pizzas. All right. And if I look at the 10 cups of cheese, I'm looking at 1 pizza for every 2 cups of cheese. So that's going to get me 5 pizzas. So obviously I can't make 3 and 4 and 5 pizzas simultaneously. One of these has got to be the actual number of pizzas I make. Well, whatever makes the least number of pizzas must be the thing that runs out first, because as I get to the first pizza, I have enough. Second pizza, I have enough of everything. Third pizza, I've just run out of sauce. I go to make the 4th pizza, I don't have any more sauce. I may have cheese still, but I don't have any more sauce. So 3 pizzas is the most I can make, and we can say that the sauce is what's limiting my reaction. Okay, and we refer to that as the LR, or the limiting reactant. So let's look at that. In case all those numbers didn't make any sense, we can do it this way. 4 crusts. It's a 1-to-1 ratio between crusts and pizzas, so I can make 4 pizzas. 10 cups of cheese. That is a 1-to-2 ratio, so I can get 5 pizzas out of that 10 cups of cheese. 15 ounces of sauce. That is a 1-to-5 ratio from our formula, so I can only make 3 pizzas. Since this is the least amount of the product that I can make, so I can't make more than 3 because then the sauce runs out. The sauce is our limiting reactant. Now, we'd actually say these also are in excess. That's kind of part of the terminology I should throw in at this point. Well, we can answer some other questions too. We can say, all right, sure, I ran out after using that 15 ounces of sauce. That was my limiting reactant. But how many crusts did we use? All right, when I'm calculating anything with limiting reactant problems, anything about how many pizzas did I make, how many crusts did I use, how much cheese did I use, you're always going to start with the limiting reactant because that's the one that's going to stop the reaction dead in its tracks once it runs out. So start with that amount. So 15 ounces of sauce. What is my crust to sauce ratio? 1 crust to 5 ounces of sauce. Okay, so 1 crust, 5 ounces of sauce. So I use that here to calculate the number of crusts. So I used 3 crusts. Excellent. So that's how many crusts I used. Well, how many crusts are left over? Well, I used 3. How many did I start with? I said I started with 4 crusts. So 4 minus 1. No, 4 minus 3, because I had 4 initially. And I used 3. So 1 crust remains. So I can say I have 1 crust in excess of what I needed. Okay, so try the same thing with cheese. Pause it, give it a shot, see what you come up with. Alright, let's try it. So again, start with the limiting reactant, 5 ounces of sauce. Now our sauce to cheese ratio is 5 to 2. Okay, so let's use that, 5 to 2 ratio. So we have 2 cups cheese for every 5 ounces of sauce from the balanced equation. So 35 by 5, I used 6 cups of sauce. Excellent. That's how much sauce I used up before the reaction came to a grinding halt and stopped because we ran out of sauce. Oh, cups of cheese. Thinking too much about pizza. But you got the idea. 15 times 2 divided by 5 would be 6 cups. Ounces are gone, so 2 cups of cheese. Cheese. Yeah. So how much cheese is left over? All right, well, how much cheese did I start with? I started with 10 cups of cheese. I just used 6 cups of cheese. From that initial 10. So that means I'm left with, or have in excess, 4 cups of cheese. Right, so when the reaction is over, I'm going to still have 1 crust left and 4 cups of cheese. Excellent. Well, we can throw a couple more definitions of things in here. One definition is the idea of yield. And yield is just how much we actually get. So for whatever reason, say something got mixed up, we added too much of something, whatever. We only got 2 pizzas, not 3. Well, we would say that 2 pizzas are defined as our actual yield. And so if the actual yield is 2 pizzas, we can say that the 3 we should have gotten is our theoretical yield. If everything had worked out exactly as planned, we would have had 3. So 3 pizzas, theoretical yield. Well, using that information, we can look at the percent yield for this process. It's just the actual divided by the theoretical times 100, and that's the percent yield for that reaction. So if we got 2 pizzas and we theoretically should have gotten 3, 2 divided by 3 times 100, our yield of pizza was about 2/3, 66.7%. All right, let's try this with chemicals. Same exact idea, nothing that we haven't done before, just a little bit more work. So if we have this following reaction, we have 42.5 grams of magnesium mixed with 33.8 grams of oxygen. So we're looking at 42.5 grams of this and 33.8 grams of O2, which should be a subscript. All right. So what's the limiting reactant? Well, it's whatever makes the least amount of product. Right? Limiting reactant makes the least amount of product. So in this case, let's find that out. 42.5 grams of magnesium. Let's see how much of the product we make. But to do that, we go from grams to moles. All right, remember our flow chart? Right. So we're in grams, so grams to moles, moles to moles. On the periodic table, we see that we have 24.305 grams of magnesium for every 1 mole of magnesium. Good. And now we have 2 moles of magnesium oxide for every 1 mole. Oh, I'm sorry, no. 2, right there, 2 moles of magnesium. So I got this 2 from there and the other 2 from here. Just taking the coefficients. So the 42.5 grams of magnesium can make us a possible 1.75 moles of magnesium oxide. Okay? We're just trying to figure out which one's going to make the most. We don't have to go to grams. We can just hold off here and keep this in moles for the moment. All right, well, 33.8 grams of oxygen. We want to go grams to moles, moles to moles again. So there's 1 mole of O2 from periodic table and adding some stuff up. 32 grams of O2. There's a 1 to 2, so 1 to 2 ratio. So I have 2 moles of magnesium oxide. For every 1 mole of oxygen I use up. So 33.8 divided by 32 times 2. No, that calculator just gave me something impossible. Let's try that again. 5 times 2. Yeah, it looks like a real number now. 2.11 moles of magnesium oxide. So this first one is if magnesium is the limiting reactant, I'll get this much. And the second one is if oxygen is the limiting reactant, I'll get this much. Well, magnesium makes the least amount. Okay, so this is the actual amount I'll end up making, and then the reaction will stop. And at that point, that makes magnesium the thing to run out first. And magnesium is our limiting reactant. Okay, now turn the product into grams to see how much we made. Okay, so once we've figured out which is the correct number of moles to use, then we'll go to grams. So 1.75 moles of magnesium oxide times, let's see, 24.305 plus 16. 24.305 plus 16. So 1 magnesium and 1 oxygen adds up to 40.305 grams per mole. So we want grams now, so those go on top. 1 mole of magnesium Oxide goes on the bottom. So 1.75-ish times 40.305. Calculator is just not cooperating this evening. 305. Yes. So this gives us about 70.5 grams of magnesium oxide. That is our yield, our theoretical yield. That's the most we can possibly make given the conditions we've described. Yeah? Alright, well, instead of the 70.5 grams we expected, say we only get 55.9 grams. What's the percent yield? Actual over theoretical times 100. It's me. .3%. And that's my percent yield. Well, good. We can ask other questions too, like how many grams of oxygen are left unused. So remember, we want to start with something that came from our limiting reactant. So we could start with the 1.75 moles of magnesium oxide, because that came from the limiting reactant calculation. Or if you want to go, just do this very carefully and from the beginning, we can start with our 42.5 grams of magnesium, because that is our limiting reactant. Let's do that. 42.5 grams. It'll come out the same either way. So 42.5 grams of magnesium. We're going to figure out how many grams of O2 are unused. So that means that we're going to have to find the number of grams of O2 that we did use up. So we can subtract it off the amount we started with. So let's start calculating from grams to moles, moles to grams. There's our flow chart. So 1 mole of magnesium for every, 24.305 grams, I think. Sounds right. Yep. And we have 2 moles of magnesium for every 1 mole of oxygen. So it's a 1:2 ratio here. 1 mole of oxygen for every 2 moles of magnesium. Good. And now we want grams again. So 32.0 grams of oxygen for every 1 mole of oxygen. So we check that everything cancels out correctly. Good. So now we just need the number. 42.5 divided by 24.305 divided by 2 times 32. And we get 27.98 grams of O2 used up. Well, that's great, but we wanted to know how much were unused. All right, so did we just do all this for nothing? No, of course not. We know that we started with 33.8 grams of oxygen. So 33.8 grams of O2 initially. We've used 27.98 grams of oxygen. So that leaves us with 5.8. We're looking at the 0.1 point or the tenths place, so 5.8 grams of O2 in excess. And that's pretty much all we can really ask you at this point as far as the chapter. So as long as you feel comfortable in that, you're golden.